This is my house. In the summer, it can get really hot inside, especially on the top floors. To solve that problem, I made a hole in the roof, so the hot air can escape. Then I made a hatch, for when it's wintertime, or when it rains. Whenever it rains, I need to close the hatch completely. And when the sun comes out again, I need to reopen the hatch. This really needs to be automated. And this handy device will do that for me. These are all the topics we need to address. You can buy this actuator on AliExpress for about $25. It comes in a Ziploc bag and contains two items. Another Ziploc bag with mounting screws and a box with the actuator. If we have a closer look, we can read some of the specs. 12 volts to run it, and it can extend 15 centimeters. The last two is speed and force, both well within range of what I want to do with it. Let's turn on the power supply to the mentioned 12 volts. When that is set, I turn the current to 0, so I can hook up the wires without shorting them. Turn up the current again, and the actuator is doing its thing. Please note the current drawn is around 4 milliamps. Now we turn off the power again and switch the plus and minus connection. Power back on, and now the actuator is running backwards. It is still consuming the same amount of current. But what will happen at the end? It stops consuming power. That is not what I expected, but it is quite welcome. We now need a way to connect 12 volts to the actuator, and also in reverse. So I borrowed a schematic from the internet. In short, this is called an H-bridge, because of its shape. Because it has 4 switches, it can connect power to it this way and turn the motor a certain direction, or this way, for the other direction. It can also do this, or both, which are shorts, and should never happen. Much of heat, house burning down, etc. Because we are going to use an ESP32, we have much control over the switching sequence. Using PNP transistors for the top switches and NPN for the bottom ones, we can send 12 volts in one direction or the other. Only need some resistors for the bases of the transistors, and we are good to go. Based on the schematics explanation I just gave, one would now expect to see a circuit with 4 transistors and 4 resistors. I expected that as well, and I was wrong. There was a problem with controlling the base of the PNP transistors at the top. The pins of the ESP32 either cannot sink current from a higher voltage source, or cannot cut off the current. The I/O pin I used for that is now broken. So for both PNP transistors, I added an NPN transistor to control the base. The upside to this is we now only need 2 signal wires, instead of 4. This is what the final circuit now looks like. Let's have a quick look at the code. I made a small sketch to control both of the signal lines. Nothing worth explaining so far. GPIO 4 high, GPIO 4 low, GPIO 2 high, GPIO 2 low, and repeat. Works really well so far. Let's get to the soldering part. It's very motivating to see something working. So the first thing I do is add a DC connector and a voltage regulator. Now the board has a 12 volt power supply and the ESP32 gets 5 volts. which it then regulates back to 3.3 volts. I now have all the components soldered as well, and there is a terminal block at the top of the board. I kept all the soldering to the bottom side of the board. Let's see this thing in action. It runs just as it did on the breadboard. I am happy with that. The sketch on the ESP32 is just a demo. It's time to put something useful in it. I made a little project for remote controlling Arduino and ESP32 devices. Let's go to GitHub and find it. In the search bar, type Crackers, that's me. It looks like there are no results, but in the left tab under Users, there is one. And it is me. Right now, there is only a single project, but just to make sure, it's called Pyduino. That's the project, alright? The top right green button lets us download a zip file of the project. Open that and extract the contents to a location you like best for that. Fire up the Arduino IDE and find the sketch in the folder we just downloaded. At the top of the sketch, we can fill in some details, pretty self-explanatory. By default, the Arduino IDE does not support the ESP32 board. But it is a simple installation. Fire up a browser and search for Arduino ESP32 board. What we are looking for is called a board URL. And most important, we need the one from Espressif. Blah blah, scroll, and there it is. We dump the board URL in the settings menu and go to the boards manager. There we try to find ESP32 from Espressif, still important detail, and install the boards, which I already have and should have cleaned up before doing the screen recording. Nevertheless, you should click install. Now we select the correct board and serial port. While that is compiling, I add the serial monitor. It should give us some info on the device. And we are online. I now disconnect the ESP and hook it up to a USB charger. Time to fire a Python and remote control this ESP from a desktop. Open up the entire downloaded project. If needed, edit the name of the device to match it the one we gave it, and fire it up. It will find the device and perform a sort of blink sketch, targeting the pin that has the blue LED on it. With this, I now have all the technology I need to open and close the hatch remotely from a central computer. That's it for this video. Hope to see you in the next one. Thanks for watching.